I don't think we could have found a better time to discuss about dust storms, given that in Cyprus, over the last these 2 days, we have been actually experiencing dust episodes. Before we talk about dust storms, I want to spend a moment to highlight the importance of air pollution and including dust storms. So air pollution is a well-established health risk factor, and there is a lot of evidence regarding the health effects of air pollution because of different epidemiological and toxicological studies, where WHO reports that air pollution is responsible for more than 4 million premature deaths as based in 2016. Also in 2019, an estimate that the majority of the world population is living in places where the WHO air quality guidelines are not met. So when we talk about air pollution, usually in our mind comes different human activities that they emit different types of pollution or pollutants. So our mind comes industrial activities, power plants, traffic, and other activities. But along with this, we also have other sources that we call natural sources, and these include, of course, dust storms and other sources like, let's say, diesel. So dust storms actually one of the significant contributors to air pollution, and it's an estimate that 2,000 million tons of dust is emitted into the atmosphere every year. And to give you an approximation, this corresponds to 100 million trucks. So medium-sized trucks that carries dust will release dust in the air every year. So we're talking about a big quantity. Okay. And that's also one of the reasons that my research focuses, of course, on air pollution based on the different health effects we have, and one part of that on dust storms. So today I would like to give you, or try to give you, a holistic description of this phenomenon as much as I can, of course, within this time, using some of my research and other research from other colleagues. So I'll start first describing this phenomenon, and then going through the different environmental implications of the phenomenon, then going to the health impacts, and then last we see whether there are any protection measures either at the national or at the regional or international level. So what we define dust storms, actually the World Meteorological Organization is having, it has one definition of it. So it defines dust storms as the results of turbulent winds raising large quantities of dust into the air and reducing visibility to less than 1,000 meters. So that's the official, let's say, definition, where within this definition actually describes the mechanisms of how dust storms are developed. So in order to have a dust storm, we actually need several things. First and most of all, we need bare soil. Ideally, it would be to have dry soil so particles can move. And of course, we need strong winds to be able to blow these particles in the air. Now, how these particles, the sand particles, move depends on their size. And when we describe particle size, we actually refer to their diameter size. So based on their size, they move through different mechanisms. So we have creeping, which this refers to particles that they have diameter greater than 500 micrometers. And these are actually dragged over the surface of the land because they're too heavy for the wind to lift them in the air. The other process is what we call siltation, which refers or involves smaller particles, particles that they have diameter between 70 and 500 micrometers. And for these particles, the wind can lift them, but briefly, because then they drop in very short intervals. Sometimes these can bounce back into the air, and then go back on the land. And then the last and the most important mechanism is suspension, which is responsible for the dust transport. These involve particles, especially fine dirt and dust, that they're less than 70 micrometers. And the wind can carry these particles over very long distances. Now you can find dust storms with different maybe definitions or with different terms. Most of the times that's because we have different types. So the one type we have, especially the ones that affect Cyprus more, at what we call the synoptic ones, which these are large dust storms, and we can see here with the blowing dust and the dust haze images. So these are caused by different meteorological causes like cold front and low pressure system, but that's more details of the meteorology. So here we see a picture of the blowing dust through a satellite, where we see masses of dust traveling through Kuwait. We see here in picture B, dust haze, which has very tiny suspended particles that remain from dust storms passing over a region and leaving a mass of dust behind that we can usually see in the sky in Cyprus. The other two types that we don't usually see here is the dust devil, which results from instability, atmospheric instability in local scale. This is usually a column of dust reaching maybe up to 300 meters. And the last one that is called habub, which habub is actually an Arabic word meaning wind. This is more prevalent to places, arid areas, and it comes or it formates when there is a cold weather in front of thunderstorms, and it creates this wall of dust and travels along with the thunderstorms. Now, where are these dust particles and where is their origin? So, of course, where they're coming from are from the hot deserts that we have all over the globe. So here in this map, we have the 10 largest deserts of Earth. The first two, of course, include the cold deserts, the Arctic and the Antarctic, which that do not contribute to dust storms, of course. But we have other dust storms, we have other deserts such as the Sahara, which is the largest one, also as the Arabian desert in the Middle East, the Syria as well. But we also have other deserts we have in Asia, the Gobi Desert, which is located in China and Mongolia. We have deserts in the North and South America, Australia, South Africa, and many other smaller ones across the world. So Cyprus is located around some of the largest actually deserts in the world, and also not only Cyprus, but other countries, especially in the South European countries, right? So this is very important in regards to European Union and European policy, because different countries in the EU are affected differently, and there is a lot of impact or contribution of air pollution from dust storms. So this actually diagram, we're seeing the African dust contribution in particles concentrations. Blue is the Mediterranean Sea, and then white is the different countries. So there's an increasing gradient from the northwest European countries to the southeast, meaning the more south or the more east we go within the Europe, the higher the contribution of dust storms in the overall concentrations. So the last thing that I would like to address before we go and see the different impacts of dust storms is that dust particles have different physicochemical properties. So their size actually varies. It could be below 1 to up to 63 microns. But the majority of particles that transported more than 100 kilometers from the source are usually below 20 microns in diameter. And we're later going to see why that really matters. Also, they have different composition. So Minerals are the most abundant elements or compounds. We also have metals and also some different bioaerosols present, so pollen, fungi, and bacteria. So crustal elements like silica, aluminum, and so on are all present in dust particles, but the percentage of those within the particles differ depending on the source of dust of the desert. Now let's see what are the impacts on the environmental impacts. But before we go to that, I would like to spend a couple of minutes talk about particulate matter, which is a very important element to describe dust storms, both on the environmental and the health impacts. So dust storms carry, as I said before, a high load of particulate matter, meaning of dust particles. And particulate matter is actually a term that we use to describe a mixture of solid particles and liquid droplets suspended in the air. And that's how we usually measure air pollution in regards to particles. So for particulate matter, we have two different types. We have what we call PM10 and PM2.5. PM10 are the particles that they have aerodynamic diameter less than 10 micrometers, and PM2.5, or the fine particles, are the ones that they have aerodynamic diameter less than 2.5 micrometers. To give you an understanding of how small these particles are, here in this diagram, we can compare the size of these particles with a human hair. So a human hair has a diameter between 50 to 70, where the PM10, you can see here in blue circles or spheres, they're actually 1/5 to 1/7 of the size of a human hair. So they're very, very small that we can barely see. PM10 usually origin from natural sources such as dust, pollen, and so on. And PM2.5 are even smaller. So there are these pink spheres that you may see. So that's even much less, so 20 and more times less than a human hair. Now, why this is important is because all the particles that are below 10 can be inhaled by our respiratory system. So all particles that are above their 10 micrometers will stay in the nose or in the mouth, and maybe by sneezing, we can remove them. Anything that is below can go deeper in our respiratory system. So the smaller the particles are, the deeper they can be found in the respiratory system and reaching maybe alveoli. Okay, so closing this parenthesis, let's go back to the environmental impacts. First of all, and most of all, dust storms affect the air quality, including the visibility in the area that's been affected. We usually describe the air quality using the PM10, where in Cyprus and other different regions, high mass concentrations of these respirable particles of PM10 are present, and most of the times they exceed the European Union daily limit of 50 micrograms per cubic meter. So let's take a dust event as an example. So here we have a satellite small video that comprises of different images from the September 2015 episode, which was a very intense episode that some of you may remember. So we can see how Cyprus is being affected by air mass that's coming from the Middle East, the Arabian, and the Syrian desert. And of course, that transfers farther down to other countries. Here are also some other satellite images where this episode started the 6th of September and lasted until the 11th. So on the 6th, before the dust arrived to Cyprus, the average for the day for PM10 was 31, which was below the daily limit. And this was a very intense episode where the next day actually increases by a magnitude of 10. It reached up to 1,000 and then went back down to 140 on the 11th. So you can imagine the dust load that these dust storms can carry, especially since we have seen how small these particles can be that we can barely maybe see with a naked eye. At the bottom, I also have 2 pictures from some colleagues that they looked at the visibility through these dust storms. So on the left, it's the visibility on the 8th. So when the dust was the highest in the peak, where the visibility was around maybe 100 meters far. And then the next day it increased from 100 to maybe 500 meters. So in actually many places where dust storms are very intense, visibility reduces so much that people cannot be outside driving or so on. Even that time, the Larnaca airport actually closed at least for a day because of the reduced visibility. Okay, so to describe a little bit more, and especially in the situation in Cyprus, the Department of Labor Inspection in Cyprus actually monitors PM10 and also other pollutants. They monitor, they have different techniques, either continuously or 24 hours averages. So here we have time series data of PM10 from 2000 to 2017. With blue are actually dust days, and in black non-dust days, and in the red line corresponds to the EU daily limit of 50 micrograms per kilometer. So from this data that we can access actually from the Department of Labor Inspection, who monitors this, we can look and examine dust storms or other phenomena, air pollution, parts of different scientific studies. So we can see actually or identify dust storms, especially if we're doing any retrospective studies. So here you can see, you know, how high some days the PM10 levels are. So we reached in 2006 and a concentration of more than 1,000 micrograms per kilometer, which is really high. And then this was associated through the back trajectories, air mass coming from the North Africa. Looking at this also data, we can also see whether we have seasonality. So we know based on the previous measurements that actually dust season is between during the late winter, so between February and May, and so late winter and spring, but also in the fall, somewhere maybe September up to November, sometimes December. And as we are facing now, we are in the November month. This data also actually helped us look at the frequency of the dust storms from 2000 to 2017, because we wanted to see whether the frequency increases or decreases over time because of different, let's say, theories that there have been around. So we wanted to examine what's the situation in Cyprus. So on overall, we identify approximately 30 dust days per year in Cyprus. In this plot, we see the number of dust days for each year. In red are the number of dust storms that they're above the 50 micrograms per kilometer, which is above the EU daily limit, and also in red all dust storms. So it includes smaller intensity of dust storms. Our previous analysis actually stopped looking up to 2010, which in a previous analysis, we found that there's increasing frequency of dust storms. But more recently, when we had more data and we expanded this analysis, we actually found that using more data and looking at the frequency of dust between 2000 and 2017 for Cyprus, there are actually no statistically significant trend. So even the frequency increased from 2000 to 2010, we saw later that it decreased, especially in 2011-12, which it was actually pretty rainy years, if you remember. We actually we examined the intensity and whether that dust intensity over the years decreased. Again, we found no statistical significant trend on that as well. But what is the future of dust storms? Can we actually say that there's no increase or no change or so on? So what other colleagues have found? So in other Mediterranean regions, actually, the findings are not conclusive. So one study found no change in the African dust contribution to PM10. Other study found increase in the frequency of the desert dust in the southeastern Mediterranean. Another study found also increase in the intensity for Israel over the last 3 years between 2001 and 2012. Another study in Spain found decrease in frequency and intensity, and a historic reanalysis that took more years found a decrease in the African dust emissions. A recent model projection suggests actually an increase in the dust storms event intensity, but future studies should examine the change of dust storms characteristics, both in frequency and intensity. We need several decades of data to look into this, and also to look into the relation to climate change, including synoptic scale conditions. What it has been suggested that what the future of desert dust will depend on is maybe depend on the anthropogenic pressure on desert surfaces, because as I say, if the soil is dry, then it's easier to have dust. So if we are doing more human activities that maybe interrupts the soil or make it drier, that will affect the future. Climatic variability, natural climatic variability. So every year the climate has different differences within the year and across the years, and of course because of climate change. Here's an example from Kuwait that shows dust storms, how are they related from different climatic conditions. So here on the right, we have that for Kuwait, dust storms are more prevalent in the summer, where we have higher temperature, higher wind speed, lower precipitation, and NDVI is actually an index of vegetation. And it was also found that there was a significant relative correlation, correlation between the number of dust storms for each year and the yearly vegetation index in Kuwait. So vegetation and other climatic parameters affect the future of dust storms. Just to close up with the environmental impacts, other impacts that dust storms might have is transport of other pollutants or substances. So as the air mass traveled from the source or the origin of the dust storms through the different maybe countries or different locations, can carry maybe either air pollutants that they are within downstream of the air. It can carry other maybe microorganisms and so on. It can affect the local climate because the particles can act as a condensation nuclei for cloud formations. Also, particles can absorb and scatter solar radiation. It also affects both the terrestrial and the ocean life because, of course, it transports sediments and other nutrients that can have negative and positive impacts actually. So for Sahara dust actually is thought to fertilize the Amazon rainforest because of iron and phosphorus transport. But also can carry other substances that they are not that may cause other diseases. So an example is the Caribbean coral reefs and how they are destroyed from the transport that we can see here from the Sahara to the Caribbean. And here on the right, we can see in green is a healthy coral reef. In the Caribbean, where in the white is actually the skin or the tissue of the skeleton is being damaged. Okay, so let's continue now to the health impacts of dust storms. Initially, what we know is the very first evidence is from what we call Black Sunday, or the Dust Bowl, that some of you may know, that happened in 1935 in the United States, where that day a huge cloud of dust covered actually 5 states. And that's because of droughts and actually intense agricultural activity in that time. And from that, the first PubMed publication on this theme came from an anonymous commentary in BMJ in 1936, which commented on a public health report article in the US referring to this phenomenon and how these 5 states, Kansas, Colorado, New Mexico, Oklahoma, and Texas, they experience similar morbidity and mortality changes. So they experience different respiratory infections and other symptoms. For the region, though, the first actually studies for the health effects of dust came in 2008, so further down and relatively recent. So the first two actually came, one from Nicosia, Cyprus, that looked in July 2008, that it was published. They looked at the morbidity and dust storms, and another one later on was published in November from Barcelona, Spain, that looked at mortality. From 2008 and after, actually more and more epidemiological evidence came into the literature and more published studies for looking more into the effects of dust storms. We have up to now, or up to my knowledge, 2 studies looking at the health effects from Cyprus. The one from my colleague Nikos Middleton found that all-cause admissions were actually almost 5% higher during dust storm days. And later on, Neofito Andreas found that there was a 2.4% increase in the daily cardiovascular mortality for every 10 micrograms per cubic meter increase in PM10 on dust days. To give you more information about the related health effects of dust storms, we'll just get some information of evidence from a systematic review that was published in 2016 from Zhang and others. And he took actually studies from different countries in Asia, Europe, Africa, and Australia, Canada, US, Caribbean, and Puerto Rico. So in this graph, actually, we see the different studies with red points, and the color field looked at the distribution of the sources. So in the systematic, this review included 103 epidemiological studies. Asian dust is actually the most frequently studied in the literature, and Sahara dust is the second most. From these 103 epi studies, 77 were published after 2008, and they looked at different health effects. So here, this diagram actually summarizes the different health effects regarding cerebrovascular disease, cardiovascular, respiratory, even skin allergies, reproductive disease, and so on. So just to give you a little bit of overview regarding dust particles and mortality, the studies looked at all non-accidental cause, respiratory, cardiovascular, and cerebrovascular mortality for dust particles. So for PM10, so PM10 levels during dust, they found studies from both positive and negative associations. For coarse particles, which is the sizes between 2.5 and 10, there was only one study that found a positive relationship. And for the smaller sizes, more studies agreed on the positive relationship as well. So the differences for the PM10 for the studies that found both that reports show both positive and negative relationships could be due to different reasons, including the fact that they are coming from different locations, different distance from different maybe desert sources, so different exposure and maybe different chemical composition of the dust itself. They looked also on morbidity and respiratory morbidity. So dust storms have been linked with asthma exacerbation and asthma hospitalization. Even there's only a few studies that focus on the association between asthma and morbidity, and dust events. So maybe future studies should maybe look into that more. Dust was found to be the major contributing factor triggering allergic rhinitis in the United States, Asian Pacific, and Latin America. Positive associations between dust storms were found for pneumonia and chronic obstructive pulmonary disease. And desert dust was also found to deteriorate pulmonary infection. Cardiovascular morbidity also increases during desert dust events. So studies looked at the emergency visits for cardiovascular diseases, ischemic heart disease, cerebrovascular diseases. They look at hospital admissions for different cardiovascular diseases, and also dust storm was associated with hypertension. Other outcomes that studies looked at maternity and reproduction. But the evidence of the impact of dust is actually scarce, especially for pregnancy. For pregnancy, a couple of studies looked at the complications and birth weight and gestational age at delivery as outcomes. Other studies look at other infectious diseases, so such for example conjunctivitis, which is the pink eye, skin symptoms, eye symptoms, but also because dust we said that they picks up and transports toxic elements and biologically active compounds. Dust storms also associated with coccidiosis, if I pronounce correct, and meningitis. And actually in this graph, we can see that the meningitis belt in the Sahara, under the Sahara belt. And an interesting assumption is that the Sahara dust may actually provide the bacteria, the meningitis bacteria, with the iron required for growth of this that cause meningitis. So our knowledge that we gain a lot from both epidemiological and other mechanistic regarding the dust and human health effects, and they're expanding, but we still need some more studies about the mechanism and also about the chronic effects of dust storms. So all the information I gave you, all the evidence is actually focusing on the acute effects of dust storms, meaning what happens within a few days of exposure. Attention can also be paid to other diseases such as reproductive system and the nervous system. And what I think also would be very interesting and important is to focus on the effects from different dust size fractions and maybe the specific chemical composition of that can affect human health more than others, so we can maybe link to more guided policy decisions and measures. So just closing up now, what are some maybe protection measures, and if there are any protections placed? So looking back in the September 2015 dust storms, I also looked at different reports and different pictures that they are out there. So here we see in Cyprus that the visibility, how much it's worse, but we can still see people outside and during the day, maybe at the beach, where the newspaper reported that dozens of people needed medical treatment for respiratory problems. Also for Israel, they was highly affected, but again, we see people at the beach, and again, over 600 Israelis, they had symptoms related to dust storms. So maybe there are not any national measures. So actually, they're not very strict measures, or they're not very well defined. So what the WHO has, actually, it was quite recent in 2016 that the guideline development group members agreed that dust storms should be addressed in the updated version of the WHO air quality guidelines. Okay. WHO believed that based on the available studies that formulating an air quality guideline level for dust storm was not possible, due to the insufficient evidence that they had for health risk-related characteristics. So they decided that the best manner to addressing dust storms is actually giving formulate qualitative practical recommendations to focus on the likely consequences. And this is regards to strengthening or establishing air quality management programs, meaning countries can have air quality program that identifies and maybe bring forecasting dust storms to give out any announcement of upcoming dust, strengthening air quality monitoring program through identification of dust sources to identify, quantify how much of air pollution is due to dust sources. There may be other sources, and maybe try to limit some other air pollution sources. Desertification and wind aeration reduction interventions, especially in places where arid environments, and urban street cleaning as a measure to limit the resuspension of dust. In the European Union region and level, there are still not specific guidelines. So what's the current idea is that, of course, dust storms are impossible to control because it's a natural phenomenon. It's also a transboundary phenomenon, meaning that it doesn't affect only the place where it's origin, but goes through other countries and affect other countries. It's impossible, of course, maybe to prevent. It's considered still not hazardous, or not as health risk as other maybe sources. And they're not non-standardized guidelines. So the overall is to advise people to stay indoors and reduce outdoor activities. So what's going on with the current moment in Cyprus is that the Department of Meteorology is forecasting dust storms, and the Cyprus Department of Labor Inspection is actually giving dust announcements based on different criteria, and it's to tell people, especially the vulnerable population, to stay indoors. This is actually very important for Cyprus and all the EU members, because they are allowed to exceed PM10 levels 35 days per year. So at the end of each year, each EU member country is reporting these exceedances to the EU. But the EU is saying that you can detect actually the exceedances from transboundary dust, especially desert dust, and you are penalized, let's say, if the exceedances due to anthropogenic sources exceed that 35 of limit. So up to date, there's no good scientific data regarding the effectiveness of any guidelines. So by saying people to stay indoors, are they actually staying indoors, and how much their exposure is actually reduced? And are these have any health effects? So we don't have scientific evidence, let's say, on that. So prior to start working at the UNIC and joining the UNIC family, I was working for an intervention study, the MEDEA, will briefly introduce, which actually this one demonstrates or aims to demonstrate the feasibility and effectiveness of an adaptation strategy to dust storms. It started in 2017, and because of COVID, of course, situations expected to finish end of 2022. And involves Cyprus, Crete, and Israel, with a coordinating beneficiary of the University of Cyprus. So what is this trying to do is demonstrate whether it's feasible to apply, first it's focusing on early forecasting of dust. So people are notified by early forecasting, maybe they in advance when the dust is coming and the intensity, like you check for weather. And then up till now, this is done through the MEDEA Actuate app that gives a notification. And it actually is trying to give some evidence of exposure reduction recommendations for dust storms that includes to reduce the outdoor exposure of people to the dust storms and also the indoor exposure by using, besides closing doors and windows, using actually an air purifier. And with the goal of transferring these results to the policymakers and other regions to follow this. Unfortunately, I don't have results to show you now, but some components of these that have been shown in other studies. So here, the effect of indoor practices during dust storms has been shown for Kuwait, where here we see indoor to outdoor ratio of PM 2.5 masses and other elements. So this is actually shows the penetration of particles, how much from outside comes inside, where we have in orange during dust and gray during non-dust events. So actually the penetration is smaller during dust, and that's because people in Kuwait follow indoor practices that keeping their windows and doors tightly closed during these severe dust storms. Maybe also residents also put wet towels under their doors and so on. So it has been shown that indoor practices can reduce the exposure to dust particles. Another study that looked at the effect of air purifiers. So this is actually the results of a school asthma study in the United States that they looked how much the PM 2.5 actually reduces having an air purifier inside the classroom. So we can see here in the left that using air cleaner actually reduces the concentrations. And they also looked at the asthma symptoms of these kids, which were again lower for kids that in their classroom had air cleaner. So just to sum up and closing here, we know that dust storms are influenced, even their natural phenomena are influenced by both natural environmental conditions, such as wind speed, but also from human activities, agricultural and vegetation removal. We know that dust particles are associated with human health effects, even we need more evidence from EPI studies. We also know that they have several environmental implications. For measures, we can do prevention and mitigation measures, and these are needed both at all national, regional, and international level, especially since it's a transboundary phenomenon. And closing here, I'd like to thank you and more than happy to take any questions. I hope I didn't take too much of your time.